Hello guys, and welcome back to my YouTube channel. This video is part of our tutorial series on C++ standard template library. From previous three video we were discussing the concept of templates because it is a prerequisite to know some basics of templates before starting the standard templates library. So in previous video we wrap up the topic of templates. Now we will finally move on to the standard template library STL concepts. First we will see some basic definition of STL, what STL is in C++. So STL stands for Standard Template Library, and it is a set of C++ template classes. Now we have seen how we can make our own templates. So STL contain templates that are predefined by C++ and they are ready to use to provide common programming data structure and functions like list, then we have stack, arrays, etc. It is a library of container classes, algorithms and iterators. It is generalized library, and so its components are parameterized. So as we can send parameter or argument list to when we call these container classes or these templates. Working knowledge of template classes is prerequisite for working with STL. We have seen some basic and advanced concepts of template classes. So STL have total 4 components. First one is algorithm, then we have our containers, then we have our functions, then we have our iterators. Now first we will see the basic definition of all of these 4 components. Then we progress in this series, we will see each of them one by one in detail with the coding examples. So first of all we have algorithms. Now what are the algorithms in STL? The header algorithm define a collection of functions. So algorithm is a collection of functions specially designed to be used on range of element. They can act on containers and provide mean for various operation for the contents of the container. Now inside of algorithms we have our sorting algorithms, searching algorithms, then we have important STL algorithms, useful arrays algorithms, then we have our partition algorithms. We will see all of them when we will start a detailed discussion of algorithms. Next we have our containers. Containers or container classes store objects and data. So algorithms are a collection of functions, and algorithms and containers contain classes which store objects and data. There are in total 7 standards first classes, container classes, and 3 container adapters classes, and only 7 header files that provide access to these container or container adapters. So first we have our sequence containers, implement data structure that can be accessed in sequential manner. So basically these sequence container are used to implement the data structure like vector data structure. We have discussed vector in our previous video, you can check that out. Then we have our list data structure, DQs, arrays and forward list. By the way, forward list was introduced in C++ 7 standard. Before C++ 11 standard we doesn't have the concept of forward list. After sequence containers we have our container adapters. What container adapter do is simply it's provide a different interface for sequential containers. In container adapters we have our queues, priority queues and stack. All of these are actually data structures. Then we have our associative containers. Associative containers implement sorted data structure that can be quickly searched by the complexity of O into log n, which is considered to be a best complexity for any searching algorithms. Inside of this we have sets, multisets, maps and multimaps. Then we have our unordered associative containers. Unordered associative containers implement unordered data structure that can be quickly searched. For example, we have unordered sets, unordered multisets, unordered map and unordered multimap. All of these was introduced in C++ 11 standard. Then we have this very simple and beautiful flow chart of how containers work. Now I will try to decode this flow chart. We will start from this basic operation. Is ordered important? If yes, then last in first out, which is also known as LIFO. If yes, if it follow LIFO practice, then it is a stack, and if it doesn't follow LIFO, then it should follow FIFO, which is short abbreviation for first in and first out. If yes, then it is a queue. LIFO is related to stack and FIFO is related to queue. And if no, then it is a priority queue, in which we set priority to each element and then get these elements according to that priority. Now if the order doesn't matter, then we have these cases. Either it can allow duplication or it doesn't allow duplication. Now if it doesn't allow duplication, then we also have two possible scenarios. Map key to value. If yes, then it is an unordered map. If it doesn't map key to values, then it is an unordered set. And if it allows duplication, then we also have two possible scenarios. First one is map key to value. If yes, then it is an unordered multimap. If it doesn't map key to value, then we have our unordered multiset. And these was example of adaptive containers and unordered containers, or you can say flow chart of adaptive container and unordered. Now we will see a flow chart of ordered container and sequence containers. So our base operation is if it is dynamic in size. If no, then it is an array, because when we discussed array in our previous video, we point out that arrays only made when we define the number of possible element that can be in that array. So it is not dynamic in size. We have to define the size of array when we are defining that array. So if it is dynamic in size, then we have a lot of different possibilities and scenarios. Does this keep sorted? If no, if it isn't sorted, then insert. Then we have if it insert or erase element in middle. If no, then we have does it insert element at front. If no, then it is a DQ. If yes, then it is precedent pointers. And from precedent pointers we also have two possible scenarios. If yes, then it is a double list, a double pointer. If no, then we have to check if its size varies widely. If no, then it is a vector. If yes, then it is a DQ. And if it does insert element in the middle, then we have to check if frequent traversal is allowed. If yes, then we have to check if size varies widely, and if yes, then it is also going to be a DQ. On the other hand, if frequent traversal does not support, then it is directly a list, double list. It is a pretty complex flow chart to understand, but if you will go through from this flow chart 3 or 4 times and takes note, you will decode it. Next we have our functions. The STL include classes that overload the function call operator. Instances of such classes are called function object or functioners, or you can say pronounce them as functors, something like that. Now they allow the working of associated function to be customized with the help of parameters to be passed. And at last we have our iterators. As the name suggests, iterators are used for working upon a sequence of values. They are major features that allow generality in STL. Now we'll see iterators, some basic definition of iterators. So iterators are basically is an object. Like pointer is an object, iterator is also an object that points to an element inside the containers. So iterator basically used to point an element inside the container. We can use iterators to move through the content of container. They can be visualized as something similar to pointer pointing to some location. We can access the content at particular location using them. Iterators plays an critical role in connecting algorithms with containers along with the manipulation of data sorted inside the container. Now the most obvious form of iterators is pointer. Yes, pointer is a type of iterator. The pointer can point to element in an array and can iterate through them using the increment operator. But all the iterators do not have similar functionalities as that of pointers. Depending upon the functionality, the iterator can be classified into broad 5 categories, as shown in the below diagram. With the outer one being the most powerful and one that sequentially the inner one is the least powerful in terms of functionality. So first we have our random access iterator, then we have our bidirectional operator followed by forward operator, and then we have our input and output iterators. Now each of these iterators are not supported by all the containers in STL. Different containers support different iterators, like vector support random access operator iterator, while list support this bidirectional operator. The whole list is given below. So we will see them one by one. For vector we have random access iterator. For list we have our bidirectional iterator. For DQ we have our random access. For map we have our bidirectional. For multi-map we have also bidirectional. For set we have bidirectional, and for multi-set we also have bidirectional. Now there are also some container that doesn't support any type of iterators, like stack, queue and priority queue. They all does not support any type of iterator. Then we have these definition of different type of operators. you can read them. Then we have this functionalities with respect to various operation that can be performed. This is an important chart, you should also read that out. So that's all from today's video. From next video we will be starting each type of container one by one. First of all, we will see algorithms and the properties of algorithms, and we will see some different sorted type of algorithms. So till then, take care and don't forget to like, share and subscribe our channel. I will see you in my next one.